So now let me switch to the approximate query processing part. So if you look at the simple query, I mean, in this case, let's say I had a 500 million, maybe 1 billion records of pricing information on instruments, and you do a simple query like give me the average of something, and you have a range query, and you do a group by that requires a full scan. I mean, you could easily run into 100+ seconds to run this thing, right? So the way we have done essentially this technique is that we can create stratified samples on your data sets. So let me go back to the thing I was showing before. So here is one example, right? What we've done, landed up doing is we have created essentially a sample on the data set. And here it's a stratified sample. I mean, there's a lot of algorithms we'll end up using, especially to compute errors. So here it's simply saying, hey, stratified on publisher, and I want to keep 3% of my thing and retain it completely in main memory. And it exactly looks like the table itself, right? Add impressions. So the key thing here is that you can add any number of samples as if they were indexes, right? That's the key thing, as if they're indexes. And you can just start running your query. So if I were to go back here, let's see, I need to probably connect here, and I'll show you really quickly. So this is, I'm using the SnappyData shell. It's a SQL shell. You can essentially obviously use a Spark shell if you wanted to work with SnappyData, or you can use any of the SQL tools out there available, right? As long as it's JDBC compliant. So let's see, I'm going to set the number of partitions here. Then if I were to run, let us say, my query. So this is the query that ran, let me set the elapsed time. So if I were to run this query, I mean, this is going to run completely in parallel and stuff like that. I have about, I think, about 30 million records, I think. Right, so about 32 million records. So if you run this, it took about 2.4 seconds or what have you. Now, if you run the same query on the sample, it takes literally about 300 seconds. And then there is a way to kind of compute an answer with proper error estimates, right? So it's the most important thing in sort of this this ability to kind of manage these sample data structures. The answer is not 100% correct, but the ability for us to tell you saying here's exactly how good your answer is absolutely paramount, right? And that's something we'll end up supporting. So if I were to show you another example here, so if you look at this thing, this is just we're taking all the airline on-time data from the Department of Transportation, and we do something very similar. And what you see here is even when you run your queries, for instance, in this case I have 105 million records, right? So if you run the same query on the sample itself, it will automatically scale the right answer, saying if you look at this answer compared to this, it's actually not correct, but still it's 99.99% correct, right? So if you look at, for instance, hey, which are the airlines that have the most flights? Fairly simple query, right? Simple, count with a group by, right? And you're doing an order by, and then saying, hey, limited to the top 8. Which are the airlines with the most flights? This is the 100% correct answer. Took 37 seconds, right? On 100 million records. Here's the same query. Again, going after the same tables, except that I added the SQL clauses. So that's one of the things we've done. We have extended SQL clauses to say, I can support a word to say, give me an approximate answer back,